Today we will discuss the propagation of EM waves for oblique incidence. So actually, as you will look into the case, normal incidence is the special case of oblique incidence. If theta is, we will see now, if theta is 0, then oblique incidence will become normal incidence. So as we took in the last case, we have an interface. Here I have a medium with dielectric constant N1, and here I have another medium with dielectric constant N2, and this is, say, so now if suppose the wave is incident like this, wave is incident in this direction, and if this is the E1 vector, E1 say I incident vector, and this is the propagation constant K1, okay, and I assume that the direction of magnetic field is coming out of the board, okay, direction of magnetic field is out of the board, and this angle is theta I. Now if this interface is the non-conducting interface, then part of this incident wave will be reflected and part will be transmitted, okay. So part is reflected back and part is transmitted. So this is the direction, say K1 R, I say this K1 I, because the medium is same here, so propagation constant will, the value of the propagation constant will not change, only the direction will change, okay. And here I have E1, and again the magnetic field is out of the board, and I say that this angle here is theta R. So this is the reflected wave, this is the incident wave, and part of it will be transmitted, what you call the refracted wave, okay. So let the refracted, this angle I will call it a transmitted wave, so I call this angle theta t, and this is the direction of propagation vector K2, because now medium is different, so the propagation vector will change, K2t, and this is the direction of E2t, transmitted electric field vector, and again the direction of magnetic field will be outwards. So now oblique incidence means at some angle with the interface it is incident, okay. So if I extend this plane, if you assume that this plane is extended like this, the light is incident on this and it is transmitted. So at z is equal to 0, I assume that this direction is x and say this direction is y, and K1 is along the z direction, okay. So along this plane, whatever is the plane, that is in the x z plane, the value of K1, K1I, K1R and K2T should be equal at z is equal to 0, that is at the origin. To ensure continuity, the value of K1I, K1R and K2T should be equal, okay. So first thing is we will write down the expression for electric field. So I can write that E1I, vector E1I is some amplitude, some average amplitude E1I into e to the power I k dot K1I dot R, K1I dot r minus omega t, where r is the position vector, and E1r vector is some average amplitude E1r e to the power I. Okay, there should not be any confusion because this is the incidence angle and here it is the imaginary I. Okay, so let there not be any confusion, they are different. So K1r dot r minus omega t. Now here we will not reverse the sign because actually the sign has not been reversed, it is now moving at some theta angle, okay, and that theta angle will be taken care in this term by the position vector r, because by this dot product the oblique incidence or oblique reflectance will be taken care. In the last case we had reversed the sign of ei, okay, that is not the case here, and I will have E2t, that is the transmitted wave, is equal to some transmitted component E2t e to the power I K2t minus dot r minus omega t. Now at the boundary, at this boundary, see from here the wave is reflected and part of it is transmitted. So I can easily say that E1I should actually be equal to E1R, this is E1R plus E2T, okay, I mean that is right also, okay. And I can say that E1R is actually equal to E1I minus E2T, right. But all these conditions are true in the tangential direction or in the normal direction. अब ये बताइए from the boundary conditions. We say that the sum of these two is equal to this. So this condition is true in the normal direction or in the tangential direction. बताइए. This condition, okay, I will explain you better. This condition is true normal to the propagation direction or tangential to the propagation direction. बताइए. Normal direction. You don't remember. We calculated if it is an empty space, then del dot E is equal to 0. So that gives me E1 dot n, that is the normal component, is equal to 0. So that gives me that all the components should be equal, then only that condition will hold true, okay. So it means normal component, all these normal components should be equal, all these normal component of the propagation vector should be equal, and I can write here that K1 dot n is equal to K2 dot n is equal to K1R, K1I and K1T dot n. This is the condition at Z is equal to 0 interface. Now if I take a look at the vector n cross r, where n is the normal component, okay, n is the normal component and r is the position vector. If I do this, then I know that it is equal to n dot r, n dot r minus, बताइए, sorry, divergence, r into n dot m, and n is the normal unit vector, r is the position vector, so n dot n goes to 1. N is the normal unit vector, okay, n is the normal unit vector. Is it clear or not? Because it is a normal unit vector that goes to 1, so I have here that n cross r is equal to n n dot r minus r. Now n dot, what about n dot r? Can you tell me what about n dot r at z is equal to 0? Zero. N dot r at z is equal to 0 is 0. So I can write that r, position vector r, is equal to n cross r. Minus, sorry, there is a minus sign here. Okay. If this is true for the normal vector, this should also be true for some arbitrary position vector at the interface. Okay. If this is true for a normal vector, this is a normal unit vector, okay, then this should be true for a arbitrary position vector. If this is true for a normal vector, normal unit vector, then this should also hold true at the interface for any arbitrary position vector. And r is arbitrary, you can choose any r. I have not put any restriction on r. So if now I substitute the value of r from there, from that equation, what I get minus, I will take only first case, I will take the first case only, okay. So if I substitute the value of r from there, then what I get is k1i dot n cross r, or I can absorb the minus sign by writing r cross n. Is it okay? I can absorb the minus sign. So from here, by the algebraic identity, I get k1i cross n dot, this is equal to k1i cross n into n cross r, k1i cross n into n cross r. So now what I get? Now this n cross r, this is a cross product, okay. At the interface, n cross r will take value 1. If at the interface, because this is the normal vector, this is a cross product, so this will take value 1, this will take value 1, second one. So what I will get here is that k1i cross n is equal to k1r cross n is equal to k2t cross n. So what I prove here is, just not the normal component of propagation vector should be equal for oblique incidence, but also the tangential component should also be equal for oblique incidence. Okay. So what is this? k1i cross n. N is the normal vector. Normal vector. So now if I see here at this point, what is, this is the propagation direction, this is the direction of propagation, okay. So what will be the normal component of k1i? What will be the normal component of k1i? यहाँ से बता सकते हैं, this angle is theta. That's good. So from here I can say, from this point I can say that the normal component is k1i sin theta I. If you do not understand like that, no issues, you just multiply them, mod of k1i, mod of n into sin theta I, that should be the angle, arbitrary angle between k1i cross n. Okay. So mod of n is 1 because it is a unit normal vector. So I will get k1i sin theta I is equal to k1r sin theta r is equal to k2t sin theta t. Now value of propagation vector in the same medium will be equal. This is what? This is modulus here. Till here it was vector. Now here it is the modulus. here it is the modulus of k, magnitude of k. So, this and this will be equal. So, if I take these two, then I get sin theta I is equal to sin theta r, or I can say from here that theta I is equal to theta r. This is the law of reflection. No, mod of k1i is not 1. Modulus of k1i is equal to modulus of k1r. They both are in the same medium, propagation vector, 2 pi by lambda. There will be no change in lambda. So, these two will get cancelled. When I take the first two terms, I will cancel them and I will get sin theta I is equal to sin theta r. That is only possible when angles are equal, isn't it? So, I get this. This is the first law. This is the basic optical law of reflection. But if I take these two, first and third, if I take first and third, and please remember, these conditions are true at the interface. These conditions, this event is happening only at the interface. Okay? We talk about refraction or reflection only at the interface. So, you can see here that reflection and refraction in light is derived from the boundary conditions of electromagnetic wave equation. And these event or these phenomenon of reflection and refraction, they take place only at the interface of a medium. It could be we are taking a case of non-conducting medium, but we can take a case of conducting medium also. Then also we will see that we will try to satisfy the conditions only at the interface of two medium. Okay. So, now if I take these two, I get k1i sin theta I is equal to k2t sin theta t. Now, do you know the relationship between the dielectric constant and propagation vector? आपको पता है? Can you tell me? बताइए. You can look into your notes. In the last turn we have done this. Propagation vector is refractive index into omega by c. Okay. At the interface, the frequency of the wave will not change. Okay. There will be no change. It is a general fact that you cannot change the frequency of a wave. You can change the wavelength, and that change is reflected on the velocity. So, ultimately frequency remains constant. Okay. So, it means omega is same, okay, c is same. Okay. So, what I get here is from that relationship I can write that n1 sin theta I is equal to n2 sin theta t, or what I get here is sin theta I upon sin theta t is equal to n2 upon n1. This is your famous Snell's law. Is it okay? So, now you can see what you can do is, now you take the oblique incidence, okay, case of oblique incidence, put theta is equal to 0, and if you are able to derive the case of normal incidence, you should be able to get whatever you get by putting theta is equal to 0 should actually be the case of normal incidence. Okay. And again it is seen that mostly the phenomenon of reflection and refraction or reflection and transmission is dependent only on the refractive index of the medium. Okay. So, it means propagation of a wave in any medium is dependent on the material property of the medium. and these material properties are permittivity and permeability. Okay. So, we know that as the permittivity is the of a medium is the ability to store electrical energy, okay, that how much charge it will allow to store within itself. Higher the permittivity, it means that medium can store more charge or that medium is more dielectric in nature. And similarly, we have another quantity called permeability. Permeability, because there are no magnetic charges, we cannot store magnetic charge. So, permeability is the measure of storing magnetic flux in a medium. How much magnetic lines of forces you can store within a medium. Greater the mu, more magnetic or more will be the magnetic energy stored in a medium. So, the medium generally we take mu naught is equal to 4 pi into 10 to the power minus 7 for non-conducting, for non-magnetic medium. Whether it is air or any non-conducting dielectric medium we take, or it is a conducting medium but it should be non-magnetic, then mu naught has the value 4 pi into 10 to the power minus 7. But the moment this value increases, as this value increases means the material is becoming more and more magnetic, and paramagnetic material have less value of permeability, whereas ferromagnetic materials can have value up to thousands. So, it means they can, under certain circumstances, they can store large amount of magnetic flux. Okay. So, there will be no storage of magnetic charge. There will be no storage of magnetic charge. Why? Because from the second Maxwell's equations we know that magnetic monopole do not exist. Magnetic monopole do not exist. Okay. So, now our next aim, so this does not end here. Now, we will have to calculate the reflection and transmission coefficient. Okay. So, that involves little bit of complicated mathematics. So, that we will take in the next turn. Okay. So, if this is not clear, you may please ask me.